It's recording.
Alright, so quiz solo. Wait. That one's here. Chelsea, Graham. Okay.
So 6, still right. Yeah, you hate to give me credit for this.
Okay, let's look at, I'm looking for, since the fourth blockers never really have a chance to ask.
Question?
Yeah, I'm gonna go ahead and do the group quiz too, super fast, and then do the solo quiz, so bear with me while we go over group. I think. There it is. All right. Okay, here we go. So we'll do group quiz first, go through everything in as much detail as we can. The two quizzes together would make a really good review of the questions for the test.
It would be pretty similar.
There were, like, some things I asked on the group and some things I asked on the solo. There was a lot of overlap, like the bottom part with the antiderivatives and area, there was a lot of overlap, but the top parts were a little different.
Yeah, because
One was calculating area, one was converting it to an integral kind of thing, so I'll just go through these as quickly as I can. Did we do these? We did them, but I don't think we recorded. Okay, let's do this. So group quiz, and I'm gonna blitz through this so I can get to the quests and whatever questions you may have today. So first we have this. They gave you this really big, long, nasty setup. Limit as the n approaches infinity of 5 over n, summation. Anytime you see these things together, limit and that summation, they're wanting you to turn this into a function. What this really means is all the area from here to here of this function. So you needed to convert this. We have 2, 3 plus k 5 over n squared plus natural log of 3 plus k 5 over n minus 1, yada yada. Okay, part A and B, what function is this and what region is this? Okay, this right here is where most of y'all probably started looking first, the b minus a over n is equal to 5 over n, which means that I'm talking about a width or a total distance of 5 units. What I don't know necessarily is where it starts and where it stops yet, okay? So then we look further into the problem, but I do know that wherever it starts, it's going to be 5 units away. Here, this is that glob of mess that got plugged into the, if you go back in your notes, the a plus b minus a over n times k thing. So this tells me that my a value is going to be 3. So I'm going to start at 3 and I'm going to go 5 units away, which would be 8. I think I just answered part B, not part A, but part B for this one. Mm-hmm. Part A is to recognize what the function is. I'm sorry, this is out of order. This crap, that a plus kb minus a over n, gets plugged in for your x value. So everywhere I see that, I'm just going to call it x. So my function is just going to be 2x squared plus natural log x minus 1. So there are the answers for part A and part B of number 1. They do not expect you at this point to do that. Even if I needed to know what this grand total answer was, I would turn it into that and plug it into my calculator and be done with it, okay? They do not expect you to do the whole limit going to infinity again. We have have much better ways. Number 2, calculate the total area. That's number 1. Number 2, calculate the total area enclosed by the graph of G, yada, yada, yada. Here's your function. X squared minus x plus 5. I think I remember listening to y'all when you were doing this one. What was the interval? I'm sorry. 1 to 4. I think I remember y'all. It was sort of a ping pong between Shannon and Michael about. Here's what you said right. You said everything beautifully. It said total area, which means we need to take all the negative area and make it positive and add all that stuff together. That's the game plan.
I think it was more me arguing with her about.
Well, y'all brought up we need to know where it changes, like where it crosses over.
So you just set it equal to 0.
So we set it equal to 0 and figure out where it crosses, and then I think she jumped in with a quadratic formula and ended up with something negative. This never crosses the x-axis. If you know what this looks like.
The square root of I, we get i's.
Right, which means it never hits the x-axis, so whatever the area is, it's either all positive or all negative. All positive. Okay, did I miss a 2 in there? I did miss a 2 in there. Okay, this graph looks something like this.
Yeah, I kind of figured this one.
Okay, and you're going from 1 to 4. So you're actually, the area you're finding is all above the x-axis, so you're good to go. So I'm just going to set up a straight up integral, go from 1 to 4 of x squared minus 2x plus 5. Because it was, you could have used your calculators if you wanted to. I think you all did, I think fourth block didn't. So we'll do this without a calculator. The antiderivative would be 1/3 x cubed minus x squared plus 5x. That's an ugly square, sorry. Going from 1 to 4, that's going to give us 64/3 minus 16 plus 20 minus 1/3 minus 1 plus 5. Okay, plugged in the 4, plugged in the 1, subtracting the difference. Lots of ways to do the arithmetic. This is kind of how I think about it. 64/3 minus 1/3 is going to give you 63/3 or 21. That's positive 4. That's also positive 4, but you'll be subtracting, so positive 4 minus 4 gives you 0. So your grand total answer is just 21. Pretty straightforward on that one. Number 3. I'm going to erase. They can pause and write stuff down if they need to. All right, number 3. Where are we? Okay. 1 to 2 of 3x minus 1 over 3x dx. Okay, this one stumped a lot of people that tried to do it. I think I heard y'all try it by hand. Did y'all start without the calculators and then give up, or did some of y'all?
This is the one this is the one where we did some, I went all the way in the circle and we gave up on it and gave to the calculators because I couldn't.
Here's what I would suggest. Look through your list. If it is one of the nice antiderivatives, we're cool. If it's not, whatever. It's not one of the nice ones, so we either use u sub or find a way to do this. Here's where the u sub gets you in trouble. If you try u equals 3x, which is what most people did, then you'll end up with something like,
U equals 3.
well, y'all would have done this. You would have said like u minus 1 over u du, or 1/3 or something like that. Okay, you're still actually not in trouble here. Not the best way to do it, but you're not in trouble here. Here's what I would suggest. This one works nicely without using u sub. If you rewrite it, split your fraction. 3x over 3x and 1 over 3x. So
it becomes 1 minus 1.
good. This will become 1 minus
1.
1/3x, or you can think of that as 1/3 times 1/x for what's about to happen. Okay, antiderivative of 1 is x. If you think of it like this, that's just a natural log, so you get minus 1/3 natural log. I'm gonna go ahead and put parentheses because we're plugging in 1 and 2, and that's not gonna hurt us. All right, stick in 2, we're gonna get 2 minus 1/3 natural log of 2. Don't really know what to do with that. Stick in 1, I get 1 minus 1/3, natural log of 1. Natural log of 1 is 0.
So 2 is,
So you get 2 minus 1, which is 1, and then minus 1/3 natural log of 2, which on a non-calculator part is as far as you get. On calculator, it would have been 0.769. Okay? Got it. All right. 4, by the way, 4 and 5 are the ones they put on the test to see who really likes bonus points. These were nice and easy bonus point questions. So 4 was if g of u is equal to the antiderivative of 1 from 1 to u of 2, dangnabbit, 2 minus x squared, I did it again, cubed dx, then find g prime. This is fundamental theorem of calculus. Your g is defined to be the antiderivative. So when you take the derivative, you're taking the derivative of the antiderivative. Those two things cancel each other out.
just replace.
All that really happens is you swap in a u for the x, and you are done.
Yeah.
No plus c or anything, okay? You are done. Now, what happens on the next one? Kind of the same thing here. D dx integral from pi 2 to x squared of square root of sine t dt.
Okay.
Okay, we're still going to do swapping out here.
You have to chain it now.
And I will reference the last one. We do technically chain it. Here's what happens. You first plug this number in, like we did here, and then you chain it. So we're going to stick an x squared in and get the square root of sine of x squared. Then we're going to chain it and get an extra 2x. We're technically doing the same thing with the second part, square root of the sine of pi 2s. But then when we chain it, the derivative of pi 2s is 0, so this whole second half gets knocked out. It does that with any constant, whether it's 1 or 20 or pi halves, whatever. Anytime you have a constant, it gets knocked out. So our final answer would have just been that, which is slightly different than what we had here. We just plugged the u in. Here we did plug the x squared in, but we had this 2x to compensate. We do technically have the derivative, but the derivative of u is 1, so it's not changing anything. All right, number 6. Antiderivative of natural log of y over y dy. This one was textbook use of. I noticed that natural log's a bad one, u's a bad one, kind of. Well, we don't ever want to let a variable just replace another one because that doesn't do any good. But if you think of natural log, his derivative being 1 over thing, there's the extra 1 over thing right there. So we have everybody taken care of. This is the antiderivative of u du. This part, the natural log, becomes u, and all this stuff right here becomes the du. And that antiderivative is just 1/2 u squared. Don't forget your plus c. So 1/2 natural log squared of y plus c. Again, relatively straightforward on that one. 7 is one that the Green Sea kids really made a mess of because they tried to overwork it. They tried to create a problem that wasn't there. Okay, so let's see, antiderivative of 2x over the square root of x squared plus 6. Again, this is a u sub, and I'm kind of thinking ahead. This is going to be my u, and I see his derivative, not in part, but entirely right up on top. So this one actually is simpler than a lot of ones we've done. We'll let u be x squared plus 6. That makes du 2x dx, and there is no doctrine. I don't need to bring that 2 over because he's already accounted for. That gives us the antiderivative of 1 over square root of u du, which I would write as u to the negative 1/2 du, and then take an antiderivative.
Green Sea tried to force a natural log or something.
They tried to force a natural log. They saw that 1 over something with a u, and the natural log is only for 1 over u to the first, okay? The reason we don't need natural log is because I can actually do this antiderivative. When you raise the power 1, you get a half. Multiplied by the reciprocal, you get 2. So my answer is 2 square root of x squared plus 6 plus c. The reason we have to use natural log is because when you have 1 over u,
It's 1 over 1.
you write that as u to the negative 1. And when you do the antiderivative, when you raise the power 1, you get 0. This is where the danger bell should be going off. You can't divide by 0. So we need something else to fix that. That's where the natural log comes in.
1 over 0 never works out well.
No, never does. Anything over 0 just causes the world to collapse. So there's number 7. Okay.
This is a 0 on 1. Doesn't mean just there's nothing there to ever. There was never something there, because you can't have something out of. When you have it's out of 0, so.
Yeah, here's the thing though.
Actually just
We have actually done a lot of work. The whole first chapter for us was dividing by 0.
Yeah.
But we were taking limits. We weren't actually dividing by 0. We were getting as close as we could to dividing by 0 without actually dividing by 0.
Yeah.
Here, if we were taking a limit, I wouldn't feel bad at all. But we aren't taking a limit. We are at that point, so
And that point doesn't
wrong.
exist.
Yeah, it's all kinds of bad. Number 8, again, calculator people, super straightforward. Non-calculator people, relatively straightforward on this one. The area, okay, so area is antiderivative from 3 to 7 of 1 over x minus 2 dx. This one by now should be screaming natural log. Should be. I'm thinking u is x minus 2, du is dx. This is a straight up swap out 1 over u du. Because it is a definite integral, you have the option. Either stay and use, and then when you flip back to x's, put 3 and 7 in, because those are x values, or go ahead and change these x values to u values. I'm kind of the second person. I kind of like to go ahead and change it to u and then not worry about making a mistake when I flip back, but whatever. If x is 3, then his matching u value would be 1. If x is 7, then the matching u value is 5, and now we never have to go back to x's. We can just leave it and use it for the rest of the problem. Antiderivative of this is natural log of u. Again, I'm going to put parentheses. I probably shouldn't do that. I probably should put absolute value all the time for you guys. But 1 and 5 are both positive, so we're not hurting anything. Okay. That's going to give me natural log of 5 minus natural log of 1. Again, that's 0, so my answer is natural log of 5, which decimal-wise comes out to be 1.609 for you calculator junkies. I'm not going to bother with the bonus. I think we put that one on the board the other day, and it's a humdinger, so we'll leave that one the way it is. Now, let's talk.
For a reason.
Yeah, it's bonus for a reason. But the bonus part, honestly, wasn't the calculus. The calculus was the easy part. It was the wall of algebra you had to do.
I think it was more like a couple walls.
Moving over to solo. Okay, this is the reaction and I'll use Green Sea because I've already taught them and gone over it with them. their thing with the top was that it was like 1 and 2, it was old, but you can't forget the roots, you can't forget where you come from. You have to be able to do it old school, or at least know how to convert from old school to new school. And that's where a lot of them, they were so used to doing this bottom part, I could do an antiderivative all day long, that they forgot where it came from.
Kinda like when we do the, when I had the 5/n plus all that, you can
Right.
turn that into a 1 bar problem.
And you could, yeah, and take off the natural, or take off the limit thing, and you could, for the fourth blockers, that's how y'all were setting them up. Y'all were actually, I think Edward in particular was